All right. Good evening, all my WOC students. This is your Vani ma'am back again with the most expected and promised video. That's nothing but MCQs for your term 1 examination, students. All right. As I said, MCQ series is going to continue. I never break my promise. I'm back again with the solid state. Today we are going to do top 50 MCQs which are important in solid state, and that too this is one of the chapter in your term 1. So welcome to all the grade 12 students and those who are joining recently into my channel. Those who are started their 11th also can watch this video so that you can start your preparation from 11th. So all the best to all the grade 12 students. Nothing to worry. I'll be sending the MCQs chapter wise, right? So basically we have alcohols, phenols, we have haloalkanes, haloarenes, we have p block elements, we have solid state, right? So nothing to worry, students. Gradually biomolecules, everything I'm going to send you. So let's start off with the session. All right, so let's go with the first question. Again, I expect one thing from you all. Please share the video, because more and more you share this particular quality and free education, the mission of quality and free education will reach many students, right? So God bless you all. Let's start with the first question. All right, so before we start the solid state, these are the summary of all the formulas which you have, which you should remember in solid state. So remember, whenever you're studying a physical chemistry chapter, try to keep your all the formulas ready so that you can apply in any of these MCQs. Okay, here I have given you what is the type or edge length, what is the formula for radius and edge length. Yes, I've given you what is the formula or number of atoms which you use for primitive, number of atoms for FCC, number of atoms for BCC. Then I've given you the formula for calculating edge length. Here again, volume of the cube. Taking the edge length, making the cube of that. Then I've given you the packing fraction. Then I've given you the empty space. So all the formulas are there in this. So utilize this table. Right, let us start off with the MCQ, students. The first MCQ, easy. Which one of the following is not a feature of solid state? All right, not a feature. So maximum questions will be of not because MCQs will always be elimination type of questions. So eliminating, you need to eliminate all the three options and one option will be perfectly right. So check that, right? So not a feature of solids. Basically, we very well know solids have definite shape. Yes. They are rigid in nature. Yes. They have definite shape. Yes. Mass and volume, definite shape. What is wrong? Yes. Solids do not flow. Frequent fluidity. Fluidity means what, students? Fluidity is nothing but tendency to flow, correct? So will solids flow? No. So tendency to flow is only for liquids. So tendency to flow is related to liquid state. That's why second option is wrong. Easy. Let's go with the next question. Which of the following is not a characteristic of amorphous solids? All right. Wow. This is an easy question again. So amorphous solid, how to remember these? One thing I'll tell you. In your house, on your dressing table, there is some white color powder which you use, talcum powder. Talcum powder, remember that. This is easy. Talcum powder is an example of amorphous solids. Now tell me, in talcum powder, will the this one, are the atoms arranged properly? No, correct? So amorphous solids, in amorphous solids, how do the substances of the atoms and molecules are arranged? They are arranged randomly. One here, one here, one here. Like this, they are randomly arranged. Correct? So amorphous solids will never have a sharp melting point. Remember. So they are non-orderly. Yes, they are non-orderly. This is perfectly right. Yes. So the option isotropy. Yes, same properties, same different properties in same direction, have tendency to show irregular cleavage. Yes, these are all properties of amorphous. This is the only property of crystalline substances. Crystalline substances have sharp melting point. Why? Because the order arrangement is very perfectly ordered like this. Because of this order arrangement, they are regular and sharp melting. Okay? Yes, students. All right. Sorry for that. Next important. Let's check Third one, which one of the following is not a property of crystalline solids? Just now we said, when somebody says crystalline solids, remember the best example as diamond. All right. Now tell me, students, diamond has very sharp melting point, but they said something, not a crystalline property. Normally, when I compare amorphous solids and when I compare crystalline solids, always remember one thing. What is that? Amorphous have isotropy, crystalline have anisotropy. Anisotropy is properties of different properties in different directions. All right, so remember this word. So what is wrong in that? Isotropy is the option. The crystalline properties are never isotropic. This is the property of amorphous. So they gave us a wrong answer. So remaining all perfect. Sharp melting point, anisotropic, wrong range order, everything right. But wrong option is isotropy. This is the property which is related to amorphous solids. Easy? Okay, let us come to the fourth question. Which of the following is a non-crystalline solid pair? Wow. They have given two options here. You have to check non-crystalline solids. So non-crystalline solids means nothing but amorphous. Correct? Non-crystalline solids are nothing but amorphous. So non-crystalline is nothing but amorphous. What is the pair, students? Yes. Check here. Wood and glass. Correct? Diamond is crystalline. One pair. If I have to say, glass is amorphous, but table salt is again crystalline. See, one is crystalline. In this sucrose and glass, sucrose is again crystalline. Why? It has two types of molecules in that. One is glucose and one is fructose. So that is also crystalline. So in this is amorphous. This is also amorphous. Perfect. Question number 5. Which of the following is a molecular solid? All right. Molecular solid, they said. See, students, ice is a cage of water molecules. Wax also is a molecule. Iodine is a molecule. So what is the correct option? D. All of these is the correct option. Yes, next comes. What type of solids here are generally good conductors of electricity? Right. We very well know covalent, there is nothing free electrons. It is shared. Shared pair. No, so they will not conduct. Ionic. Yes, they are ions. There's a cation and an anion, but do you have any free electrons? No. Molecular solids are formed by sharing, again no free electrons. What is left out? Metallic. Whenever somebody says metallic bond, what should you remember? It's a bed of or a sea of electrons. Sea of electrons. Because of this sea of electrons, metallic or metallic bond or those who show metallic property are very good conductors of electricity. Conductors of electricity. Correct now, students? All right. Now let's see question number 7. Among the following, which is or not a crystalline solid? All right. They're asking you which is not. Simple. NaCl is a crystal. Okay. Sucrose is a crystal because it is made up of sugar crystals. Just now I said it is made up of glucose and it is made up of fructose molecules, which is a crystal, right? What is not? Yes, it's nothing but glass. Glass is called a pseudo solid. Remember, it is an amorphous solid. It tends to flow. Correct? Yes. Question number 8. Graphite is a good conductor of electricity due to the presence of what? Easy question. Yes, just now I said when somebody talks about electricity, think in terms of free valence electrons. That free valence electrons will start conducting current or electricity. Question number 9. Wow. The total number of crystal systems and the number of Bravais lattices are what? Right. Basically, students, always remember. Crystal systems are 7. What are they? Yes, right. You all know. Correct. Cubic, tetragonal, orthorhombic, rhombohedral, hexagonal, triclinic, monoclinic. You remember? Hexagonal, like that. These 7 crystal systems, they recombine and form. What do they do? They recombine and they're going to form 14 crystal systems. These 14 crystal systems are nothing but Bravais lattices. Remember this. Okay, students. So what is the ratio? 7 crystal systems and 14 Bravais lattices is the answer. So which is the correct option now? B is the correct option. Okay. All. Next question. Question number 10. Out of 7 crystal systems, how many have body-centered unit cell? All right. There is a table for Bravais lattices, students. There's a table for Bravais lattices. I have also shown in my video. So in that Bravais lattice, for example, if I take your basic hexagonal. In hexagonal, what are the different combinations? I have given list. This forms BCC type, this forms end-centered type, this forms ECC type, like that. So they are asking you which out of 7 crystal systems, which one is having body centered. So please study the table, watch my video where I have shown that. So basically the out of 7 crystal systems, BCC unit cell is observed. Means how many can have BCC? 3 crystal systems can have BCC. So please observe that and read that table. So in that I have given you this. Question number 11. Among the following unit cells given below, which has the highest symmetry? Alright students. So basically again Bravais lattices only. Among everything, cubic system has the highest symmetry. If I take like this, perfectly the cubic system, yes, your edge length A, edge length B, edge length C, all the ABC edge lengths, alpha, beta, gamma, all have 90 degrees. So please note the highest symmetry is for cubic system. Perfect. Question number 12. Sorry, 12. Oh, right, missed out. Question number 13. In which of the following crystals the end-centered unit cell? Again, I'm telling you systems. Students, please learn the table. Table of Bravais lattices is very, very important. Alright? Fine. So basically, 13th question. In which of the following crystal systems the end-centered unit cell exists? Nothing but monoclinic. All right. So please read the table again. Fine. If A, B, C are unequal, right? Alpha, beta are unequal and not 90 degree, it represents which? We very well know for a unit cell, you have two parameters to consider. What are they? Edge length ABC and alpha, beta, gamma angles. Correct? So they said this and this, it is not equal. They said A is not equal to B, B not equal to C, and alpha, beta, and gamma are not equal to 90 degree. This is what they said. So which is that system, students? Basically, yes, it is nothing but triclinic system. So please learn all the parameters from the table. Fine. Next. So I'm showing you how they're going to ask you questions in the exam from the table. Fine. The empty space left in the hexagonal close packing of spheres in 3 dimension. Fine, fine, students. So basically, HCP packing. Always remember HCP packing. Don't get confused. CCP packing. Don't get confused. FCC packing is the same. Means packing type is different. Right? If I take HCP, here you have AB packing. If I take CCP, you have ABC packing. But the packing fraction is all the same. Remember, so they said empty space. So how much is the packing, students? In HCP, CCP or FCC, packed part. How much is packed? Packed part is 74%. Okay, out of 100. Now empty part, empty space is how much? 26%. So total 100%. So empty is 26. So they said HCP packing. So I'm marking this. Easy. Now question number 16. Which of the following is not a closed pack arrangement? All right. Fine, fine. So basically students, when I see all the three rather, you should remember in CCP how much is the packing, HCP how much is the packing, in BCC how much is the packing. So when I see BCC packing, you only know, no students, it is not less. The empty space is more in that. Empty space is more in that. Say cubic, if you see 52.4 like that, BCC if you see 64, 764 and then 74 in that. So which is not closed packed compared to this? Yes, this and this are FCC, 74%. Less than that is BCC. So in this which is not closely packed, not tightly packed. There are a lot of spaces in between. Okay, so BCC is the answer, not these, not this, not this. This is the answer. The void formed by close packed array of spheres located at the alternate corners of each face is. All right. Yes. So array of located at the alternate corners. So normally remember students, whenever we say voids, carefully remember this is your triangle, right? Like this. So if I divide this into like in this part, observe this whole, okay, exactly in this. So for each cube or each unit cell, when I take one frame like this, see here, this is one frame like that. Remember, number of tetrahedral voids are 2n. Number of octahedral voids are n. So what did they say? The void formed by closed packed array of spheres located at the alternate corners of each face. So alternate here, here, alternate faces. What is it? It's nothing but tetrahedral void. Remember that. So alternate corners, if they say it is tetrahedral. Body diagonal, then you can say it is octa. Okay. Then 18th. What is the contribution of atom present in H center of a unit cell? H center. Okay. This is my unit cell. Okay, now we very well know this is one edge, this is one edge, this is one edge. What did they say? Edge center. Now see students, all the atoms are at the corners. Now I have all the atoms in the corners. So how much do they occupy? This occupies 8 into 1 by 8 is equal to 1 atom. Now what is the center of the edge? Now let us take this is one edge, this is one edge, this is one edge. Now I'm going to place one atom in the center. Now tell me, this is 8 into 1 by 8. It is exactly half. Exactly half. Isn't it? Isn't it 1/4 of this? 8 into 1 by 8 at the corners. In the center is 1. Edge center this set. So 1 by 4th is the edge center. Here 1 by 4th. Here 1 by 4th. Okay. So the option is this. So analyzing the question is only the magic. Alright students, did we mark it correctly? Yes, correct. Next, the pattern of successive layers of CCP arrangement can be designated as what? Alright, I said something just now. HCP packing is always ABAB type. This is three-dimensional. Okay. CCP packing is always ABC type. So when they say CCP, remember the type of packing is this. Okay. Now, next. The density of the crystal D is given by the formula. What is the formula? Easy. Density formula is this. Direct. Correct? Alright. Where Z is the number of atoms, M is a molecular mass, A cube is a volume, and Na is a Avogadro. Easy? Let's see. 21st question. The total number of tetrahedral voids in the face-centered unit cell. Oh, easy question, students. So, remember how to calculate TB. How to calculate OV. I'll tell you. Easy. CCC. FCC number of atoms are how many students? FCC number of atoms are 4. So formula for TV is 2 into N. This is N. So for FCC atoms are 4. So 2 into 4. 8 TVs will be there. How many OVs will be there? Only 4 will be there. Let us take BCC. BCC number of atoms are 2. So 2 into 2. How many TVs will be there? TVs. How many OVs will be there? 2 OVs. Easy? Yes. Right. That is how you're going to calculate the TVs and OVs. Easy. So what is the number of atoms in this? Nothing but option B is a thing. Right. So option B is the correct answer. Right. Perfect. Now let's see this question. The defect, or once again students, let me check a little bit my camera. All right. What did they say here? Which of the following point defects are shown by AGBR crystals? Right. Remember students. AGBR. Right. What is the speciality of this? AGBR in this, both your cations and anions are of the same size, students. Both the radius ratio of the cation and anion is same actually. That's why what will they do? AGBR radius ratio, let us take. Radius of anion and cation are same. So AGBR is a crystal. AGBR is a crystal which is going to show both Schottky defect and Frenkel defect. Which option is right? A option is right. Clear? All right. Next question. In which pair most efficient packing is present? Okay, right. Just now I said. So basically when I take HCP and CCP, the packing is maximum 74% in this. When I take BCC, how much is it, students? 68%. Correct? Yes. When I take simple cube, it is around 52.4%. All right. Right. So you all remember the things once again. Sorry, I'm just getting a this one. So we have studied the packing efficiency of these simple cube. So BCC packing, once again, students. Sorry. I'm just getting a call. All right. Sorry. Once again. So when we see this, sorry, I'll disconnect it. When we see the packing of these, so here maximum, always remember HCP or CCP or FCC is maximum. Then comes BCC, then comes simple cubic. Okay, so remember these perfectly. Understand. Question number 25. Which of the following statements about NaCl crystal is correct? Fine. So remember, NaCl crystal is going to show, or when I take this crystal, here you are going to see that, always remember, chloride ions are the corners. So NaCl is going to show me a simple cubic lattice where any chloride ions are present at the corners and Na ions are present at the body center. So NaCl, if you see, it is BCC arrangement. Remember that. Yes. So next. Which of the following statement is not true about hexagonal packing? Which is not true, they said. Remember, students, remember, HCP packing is always AB type. That means if I have an A layer here, right, on the above, you have B layer. So on the above, A layer. On the above, B layer, like this. So this is the first layer. This is your second layer. This is your, again, third layer. This is your fourth layer. Now what did they say? What did they say? Now see, fourth layer and the second layer are same. Correct? Fourth and second are same. Fourth and second are same. Then third and first are same. Correct, no, students? Yes. So what did they say which is wrong? Among all these, in this arrangement, spheres of the fourth layer are exactly aligned with the first layer. Wrong. No, students? See here, fourth and second are same. But here what did they say? Fourth and first are same, they said. That's why this is wrong for us. It's not true. But this is true statement. Perfect. Next, let us see 26th question. Which of the following is, among the following, is likely to have Schottky defect? All right. Schottky defect. I said something. In Schottky, what will happen, students? In Schottky, what will happen? So basically, the cations are missing from the lattice side. Correct. So here, among these, zinc AGBR shows both Schottky and Frenkel. NaCl is the only thing which shows Schottky. So examples of the defects, remember, examples of each defect is very important. Okay? Learn all the examples. Fine. Okay. Next. Zinc oxide is white when cold and yellow when heated. It is due to the development of what? Whenever somebody says color property, remember that, students, what happens? Zinc oxide breaks up into Zn plus 2 cation and half oxygen anion. Half and half gets cancelled and becomes O. So this Zn plus 2 excess goes and occupies the lattice site. Excess Zn plus 2, whatever is there, it occupies this. So here, this is due to metal excess defect. Inside the lattice, metal would be excess. Here, all right. Next important thing. Which of the following is not the correct consequence of Schottky defect? Right, students. See here, there is a concept called Schottky. There is a defect called Schottky, and there is defect of Frenkel. So always make one table like this. What happens in Schottky when density is there? What happens to the crystal? What happens to the neutrality when Schottky is there? Right? What are the examples of Schottky? What are the examples of Frenkel like that? So among all these, remember, whenever there's a Schottky defect, yes, just there is movement of the cation out. Yes. So nothing, the cation moves out of the lattice. Right. Is there any change in the lattice energy of the crystal? No change. There will not be any change in the crystal. That is only dislocation. It is moving out. So this option is wrong. Density decreases, stability decreases, electrical conductivity increases. Perfectly accepted. But lattice energy will not change. Remember. Next comes 29th question. In Schottky defect, dash is occupied. All right. What did they give me? Yes, I said. In Schottky defect, perfect students, one of the cation site gets vacant. It moves out. So some of the lattice sites are vacant. That's why no, the density reduces. Yes. All right. Next. In a closed packed array of n spheres, the number of tetrahedral holes are how many? I said formula for PV is 2n. Formula for OB is n. So number of n spheres are how many? Yes, closed pack array. Let us see the 31st question. Which defect cause decrease in density of the crystal? Which will cause Schottky defect. Schottky defect because cation goes out from the lattice site, no students. So the density of the crystal decreases in Schottky. Okay. Let us see 32nd question. Which of the following defects is also known as dislocation defect? Fine, fine, fine. Just now I said, in Schottky, cation moves away from lattice side. So for you all to lattice side, for you all to remember, right? This is cation moves from the lattice side. But what is important, students? Here, important cation is missing, anion is missing. Correct? To balance that, cation and anion also are missing. But here in Frenkel, I've given the clue already. In Frenkel, what happens? One of the cation escapes. Cation escapes, only cation. Here cation and anion balanced, both moving out. So cation escapes and occupies the interstitial space. That's why it is called dislocation. So for your proof, I have given the answer here. Check. Okay. Alright. So what is the answer? Dislocation defects are nothing but Frenkel defect. So in the earlier case also, I said Schottky. Why? Why is the density decreasing? Cation and anion are missing out from the lattice site. Clear? Alright. Let us see Frenkel defect. Frenkel defect is noticed in which? All are examples, students. These are all examples of Frenkel defect. You can easily take and note them as an example. Next, let me drink some water. Next, the defect which an ion occupies on interstitial position in the crystal lattice spot. So just now I said, in Frenkel defect, a cation occupies interstitial space. Correct? Cation occupies interstitial space. Right. That's the defect. All right. 35th question. In CaF2 structure, calcium plus 2 ion form CCP and F minus occupy what? Alright. Here they have given a clue. Easy clue. Nothing. They said CCP structure. In CCP structure, you tell me students. In CCP, what is the formula? I said always tetrahedral voids are double. Octahedral voids are half. So see here, all the tetrahedral voids are occupied. So double everything. Next. And 36th question. if the ratio of the coordination number of P to Q be Y is to Z, then the formula of the solid is, yes, now the ratio of P to Q, right? What did they say? The ratio is P, this is Z. So whenever you have a ratios, what do? You cross it, correct? You cross the ratios, fine. So the formula becomes, yes, what does the formula become? It becomes P, Z and Q. Easy? Easy. Now, question number 37. See this. The general formula of an ionic compound crystallizing in zinc blend is nothing but zinc sulfide. This is the zinc sulfide. Now, what is the formula they said? How will I know this? Now you only see this, students. Yes. So zinc blend, zinc valency is how much? How much is valency? +2. Sulfur valency is how much? -2. +2 and -2 gets cancelled. Equal number. So what is the formula now? A is zinc, B is sulfide. So the formula is AB. Easy. That's why this is the option. Right, students? Easy. Now, 38th question. Which of the following statement is not correct? They said which is not correct. All right. Now, let us see one question. One and eliminate it. The density of the crystal exhibiting Frenkel defect is less than the compared to that of perfect crystal. No, wrong. This statement, first statement only is wrong. Correct, no, students? Whenever there is a Frenkel defect, automatically cation moves out of the lattice and they will be tensed. So perfect crystal is no problem in perfect crystal, but when there is Frenkel defect, the density of the crystal will be, it will, the density of the crystal will change due to the defect. So first option only is not correct. They said it is less. But what is the correct option? It will be more. Right? It will be more. Yes. Easy. Next. 39th question. Which of the following statement is not correct? Oh, they've given this question. Not correct. Let us see. Heating of zinc oxide leads to the formation of yellow color non-stoichiometric compound. This is perfectly right. It forms. Yes, it forms. Just now we have seen. The creation of cationic holes in ionic crystal imparts electrical conductivity to such crystals. Yes, when there is a cation, when the cationic holes are there, the electron goes and occupies and it forms or it imparts color. Right, that is also right. The compound ferrous oxide can be prepared in stoichiometric ratio. This is the not correct. FeO, ferrous oxide, always, now remember, iron exists as +2 and +3 oxidation states. Yes, it will never be in stoichiometric ratio. The ratio will be 0.9593. Both the ratios will be there is to 1 of oxygen. So it exists in two different ratios. It is never stoichiometric. FeO is a non-stoichiometric defect. Non-stoichiometric defect. Remember that. Okay? So they have given wrong option here. I have marked the question number 40. If Z is a number of atoms in the unit cell that represents the closest packing sequence, ABC, the number of tetrahedral voids are how many? Yes. Just to confuse you all students, they have given this packing ABC. Okay. Nothing, it's nothing but your CCP packing. Correct. Right. So whatever it is in CCP, the number of tetrahedral voids is 2n, TV. Number of octahedral voids is OV. Fine. Now check what is the formula? 2 set. Correct. 2n or 2 set. Easy. Let us see the 41st question. In face-centered cubic unit cell, the edge length is what? I have shown one table, no students. You remember? Initially, I have shown one table. So, yes. For FCC, what is the formula? Root A is equal to 4R. Yes, correct. A is equal to 4 by root 2. So, which is the second? Easy? Alright. Let us go with 42nd question. Fine. The correct order for the packing efficiency in different types of unit cells. I just now told you, isn't it, no students? Just now I said packing efficiency among everything. Learn the percentages. सबसे ज़्यादा, the one which is maximum is FCC, 74%. Next is 68% BCC. Next is 52.4% simple cube. So the correct option is FCC greater than BCC greater than, don't get confused, FCC, CCP, HCP, same. Okay, only packing type is different. Now, 43rd, NaCl shows Schottky defect and AgCl Frenkel defect. Their electrical conductivity is due to what? Okay, Schottky and AgCl Frenkel. Right. Now you only tell me, students. You only tell me. What will do? In NaCl, what are there? Na plus and Cl minus ions. AgCl is what? It's covalent. Correct. It's covalent. So what will be there in this case? Electrons. Perfect. From one more electron are transferred and it forms a bond, covalent bond between them. So what is the correct option? Yes. So the defect in NaCl is due to ions. The defect in AgCl is due to electrons. Perfect. Alright. 44th question. Amorphous substances show. Yes. Yes. Carefully you should read. Short and long range order, short range order, long range order have no sharp melting point. So please be careful with this. Just check amorphous substance. I have to clearly see. Observe carefully. They show short range orders because they are irregular. They are irregular in nature. And second important thing, they are, if I have to say, there is no sharp melting point to this. So because they are irregular, which is option right? Option B, 2 and 4. So correct option is this. Clear, students? Easy. Now question number 45. Let's read this question. A compound contains two types of atoms, A and B. It crystallizes in cubic lattice with atoms X at the corner and atoms Y at the body center. Take a cube like this and make the atoms. Join all the atoms. Where are X, students? X are present at the corners. So X, all the X's are present in the corners. All the corners are occupied by X. Perfect. Done. Then what did they say? They said Y is present at the body center. Okay, Y is here, it seems. Our Y is here. Now, what is the formula of the compound? They said. Okay. Now, observe carefully, students. 8 corners. So, X is contributing how many? 8. Each is contributing 1 by 8th part. One atom. Y is the body center. So, only one. It's not shared by anything. So, one atom. The total 2 atoms. Now check X is how many? 1. Y is how many? 1. So, the formula is XY. So, the correct option is easy. 46th question. Let us see, students. Let's see. A metallic crystal crystallizes in lattice containing a sequence of layers A, B, A, B. So once they say A, B, A, B, immediately it should click in your mind. A, B, A, B type of packing is in HCP. ABC, ABC type of packing is in CCP. Okay. Any packing of spheres leaves out voids in the lattice. Okay. What percentage by volume of this lattice is empty? HCP, what is the percentage, students? HCP, what is the percentage? You only tell me. Packed is 74. Empty is 26. Empty is 26%. Okay. So what is the correct option? A. Yeah. Okay. Next. For a solid which with the following structure, the coordination number of the point Q. Okay. Now see, students. This is simple cube with face centered. Correct. So what is the coordination number? Next, you see, students, for a simple cube with face centered. See, you have atoms on the faces. So what is it? Face centered. The coordination number, the number of surrounding atoms. It's nothing but 6. Correct. Right. Easy. Fine. Let us take 48th question. An excess of potassium ions make KCl crystals appear violet or lilac in color. Since, so I said whenever some crystal is going to show color, every time remember, because of the excitation of electron. When the electron from the ground state, it goes to the excited state. It is unstable here, right? During this process, what will happen? It will come back to the ground state. During this process, it's going to absorb a particular color from the spectrum. So this absorption of color from the spectrum gives the characteristic color. So this is nothing but F centers, we said, F centers in the crystal. So KCl is, what is that? It's appearing in the violet color range. The electron is going to appear from the violet. So what is this because of what? Because of presence of anionic. So what happened in the KCl crystal? K plus, Cl minus, K plus, Cl minus were there. One of the chloride ion vacancy is created. So the electron, when K and this one KCl are breaking like this, K plus and Cl minus, that electron comes and occupies this site. So this site is nothing but F center, right? So because of which one, students? Which one is the color? So remember, the some of the anionic sites are occupied by AC. Okay. Next question number 49. In a compound, nitrogen atoms make cubic closed pack lattice. M occupies 1/3 of the tetrahedral voids. Determine the formula. Easy, students. What did they say? N occupies CCP lattice. Perfect. M makes 1/3 of the tetrahedral voids. Correct? 1/3 of TV. Okay. How many TVs are there? TVs are 2. So 1 by 3 into 2. M is equal to 2 by 3. How many atoms are there in cubic closed packing, students? How many atoms are there in cubic closed packing? Number of atoms are 1. So make this ratio M is to N. 2 by 3 and 1. Now when it is a ratio, what do? You cross it. What do you get? You get M2. Yes, students, you cross it. Yes, M2N3. So the formula is M2N3. Easy. All right. Last question, students. Assertion and reasoning. The total number of atoms present in a simple cube unit cell is 1. Reason they give. Simple cubic unit cell has atoms at its corners, each of which is shared between 8 adjacent unit cells. Once again, always understand. Assertion is a fact. It's a fact. That means sky is blue in color. It's a fact. Reason is a statement which supports the fact. It may support the fact, it may not support the fact. Yes. Now let us see this. The total number of atoms present in a simple cubic unit cell is 1. Is it right? Yes. Yes. Simple cubic unit cell, the number of atoms is 8 into 1 by 8, 1 atom only. Perfectly right. Assertion is right. Simple cubic unit cell has atoms at its corners, each of which is shared by 8. Perfectly right. See here, I have just now made, I have 8 atoms and each atom is shared by 1 by 8 part of it. Right? This is also right. So assertion, option A is right. Yes, assertion right, reason right. Reason is the correct explanation for assertion. Perfect, students. Yes. See, thank you so much. Okay, wait. Let me come back to the previous slide. Okay, so thank you so much, students. What did I do? I'll go back to the previous slide. Okay, and God bless you all. I have done 50 MCQ question. So let me thank all of you once again for watching this video. Thank you so much. So I'll be meeting you again with one more chapter, right? Please share the video. Share the video how much ever you can. It's free, students. Sharing is always free, correct? So please share the video. I'll come back with the next chapter of term 1. Next chapter of term 1. I'm going to cover the whole chapter. WC is always with you all. WC, your Vani ma'am, is always with you all. All right. Bye bye. Please share the video. Thank you so much. God bless you.